Breaking news, I'm Grayson Punzalan, and today is a special commemoration of the great physicist Max Planck. Who is Max Planck, you may be asking? Why don't you tell him, John?
Well, okay then. Max Planck was born on April 23rd, 1858 in Kiel, Germany. That's where they're known for their international sailing events. He attended college at Ludwig Maximilian University of Munich and Humboldt University of Berlin, where he received his doctorate of philosophy by Kirchhoff and Helmholtz, who are some very smart people. His first publications, however, were in the field of thermodynamics, mainly due to his admiration of Kirchhoff. He did, however, have interest in wavelengths and energy. Eventually, he found the relationship between the energy and the frequency of radiation, which became known as Planck's constant. Alright? So this turning point in physics led to his foreign membership of the Royal Society of London, where he received the Copley Medal for his renowned scientific discovery. Later on in life, with the Nazi occupation in Germany, he felt obligated to stay in Germany, even though he did not fully agree with all their ideas and the ways that they were doing things. And it didn't help much how his house was destroyed in a bombing, which looked something like this. Boom! Alright? His family life wasn't so successful either. He had to marry twice, and he had 5 kids, 3 of which died young, and 1 that died in a failed assassination attempt of Hitler, which left him with 1 child. He eventually died in Göttingen, Germany on October 4th, 1947. Now let us have a moment of silence.
Thank you, John. Now, Steve, why don't you explain to them what Planck's constant is?
Okay, well thanks, Grayson. And as you can see here, Planck's constant is 6.626 times 10 to the negative 34, and its units are joules times seconds. And Planck's constant is going to be used in the equation E equals H times V, whereas E is energy equaling H, which is Planck's constant, times V, which is frequency. Alright? And the H value is always going to be 6.626 times 10 to the negative 34 because it's a constant. Constants can be thought of as rocks, alright? It's never going to change. It's always going to stay the same. Alright, so in this equation, you're only ever going to have to solve for E or V because H is always given. Alright, Tom, why don't you show us how to do some examples?
Sure thing, Steve, but let's take certain precautions because we are working with Sharpie here.
So for the first problem, let's just say they give us a frequency of 4.80 times 10 to the 14th seconds to the negative first. So we're going to plug that into the equation E equals H times V. Add in Planck's constant, because that's what H is equal to, and then put in the frequency. Alright, and then the seconds are going to go cancel out, leaving us with just the joules, leaving us with an answer being 3.18 times 10 to the negative 19th joules. Don't forget to box your answer and sig figs. Don't forget.
Thanks, Tom. Rick, why don't you show us number 2?
Okay, for the second problem, let's just say we have to solve for frequency this time, where they give us the energy, being 3.18 times 10 to the negative 19th joules. Okay, we're going to plug it into the equation, equaling it to Planck's constant. And we're going to multiply that by the frequency, which is what we're solving for. And then to isolate the frequency, we're going to divide by Planck's constant. Cancels out. And then we're going to cancel out the joules, leaving us with 1 over seconds. And then the answer to the frequency being equal to 4.80 times 10 to the 14th seconds to the negative first. Again, box your answer and don't forget about sig figs.
Nice, Rick. Fred, why don't you mix it up a bit? Say no more.
So for this third problem, it says wavelength of 625 nanometers, find energy. And I know what you're thinking, what's wavelength? Like, get that away from me, I don't know what it is. Well, it's not that bad. So first off, we're going to convert the 625 nanometers into meters by multiplying it by 10 to the negative 9th meters over 1 nanometer. Units cancel out, and the answer is going to be 6.25 times 10 to the negative 7th meters. So that's the wavelength. And we're going to plug that into the equation. C equals this funky looking letter times V, where C is the speed of light, this funky looking letter is wavelength, and this is frequency. And since we're solving for frequency, we're going to change the equation to look like this, equals V. And C is the constant, right? So this is going to be 2.998 times 10 to the 8th meters over seconds over the wavelength, 6.25 times 10 to the negative 7th meters. The units are going to cancel out, leaving us with 1 over seconds. And the answer to the frequency is going to be equal to 4.80 times 10 to the 14th seconds to the negative first, all right? And we're going to plug this, the frequency, back into the equation. E equals H times V. And, all right, and then when we plug it back in, we plug it in, plug in Planck's constant, and then find energy, which is 3.18 times 10 to the negative 19th joules.
Well, that concludes your special commemoration for Max Planck. I hope everyone learned something. And I'm Grayson Punzalan.
And I'm Fred.
And this has been Gimme an A News. And we're out.